everyone, today I want to look at prime numbers and then how to create factor trees. So hopefully you've heard of prime numbers before. They're essentially numbers that don't have any other factors other than the number 1 and themselves. And when I say factors, what I mean is there are no numbers that multiply together to give us that number except for the number 1 and that particular number. So for example, the number 7. There are no numbers that multiply to make up the number 7. I can't go 2 times anything, gives me 7, or 3 times anything, or 4 times anything. The only way I can get 7 by multiplying is 1 times 7. So it's only the number 1 times the number itself. So that makes the number 7 prime, okay, because it doesn't have any other factors. Whereas if I look at the number 6, I can go 1 times 6, or I could go 2 times 3. So it is a composite number. So it's not prime, it's composite because it's composed of lots of different factors. Okay, cool. So let's quickly go through these numbers and figure out which ones are and which ones aren't prime. So now the number 1 is a really funny case. Historically, some people have said that the number 1 is prime, and then basically the general consensus now is that the number 1 isn't prime. It's a special kind of category. It's not composite and it's not prime. It's its own like magical little number. So I'm just going to sort of exclude it from our trying to figure out which is prime, because yeah, technically it's not prime, but some people say it is, but it isn't. Anyway, whatever. All right, so anyway, the way you get the number 1 is by timesing 1 times 1. The way we get the number 2 is timesing 1 times 2. There's nothing else. There's no other way to find the number 2. So that makes the number 2 prime. Same as the number 3. I actually won't write the times there. I'll put a little comma to list my factors. Whereas the number 3, how do I get the number 3? 1 times 3, and that's it. That makes the number 3 prime. Let's have a look at the number 4. The number 4, I can go 1 times 4, or I could go 2 times 2. So that means that 4 is not prime. It has 2 sets of factors, which is awesome. It's a composite number. Whereas the number 5, I've only got 1 and 5. It's prime. What about the number 6? I could go 1 times 6, or I could go 2 times 3. So it's got 2 sets of factors, which means it's not composite. It's not prime. It is composite, it's not prime. All right, 7, I already mentioned, there's no way to get 7. It's prime. Number 8 can be made up of 1 times 8 or 2 times 4. So it's composite, not prime. The number 9, I could go 1 times 9, or I could go 3 times 3, which means it's not prime as well. Number 10, I could go 1 times 10, or I could go 2 times 5. So it's composite. Let's move down here to 11. So to get 11, I could go 1 times 11, and that's it. Means it's prime. What about 12? I could go 1 times 12, I could go 2 times 6, or I could go 3 times 4. It has quite a few sets of factors, so that means that 12 is not prime. What about 13? I could go 1 times 13, that's it, it's prime. What about 14? I could go 1 times 14, I could go 2 times 7, and that's it. Oh, so why am I circling? It's composite, not prime. My bad. What about 15? I could go 1 times 15. I could go 3 times 5, which means it's composite as well. Let's look at 16. I could go 1 times 16. I could go 2 times 8, which means it's composite. What about 17? I could go 1 times 17, or I could go nothing because it's prime. What about 18? I could go 1 times 18. I could go 3 times 6, or I could go 2 times 9. So that means that it's not prime. And 19, I could go 1 times 19, and that is all, folks. And lastly, I've got the number 20. I could go 1 times 20, I could go 2 times 10, or I could go 4 times 5, which means it's composite. All right, so what we've just done is we have just identified all of the prime numbers between 1 and 20, and they're circled here in blue and green to try and make them look lovely. And then we've also listed all of the different factors for each of the numbers between 1 and 20. So now what we want to do is we want to create a factor tree. So what that is I pick a number, but I don't include the number 1 on a factor tree, okay? Because the number 1 is a special kind of number, it's not composite and it's not prime, so I don't include it, okay? But what I do is I pick a set of factors for 12. So we've got 12 here, we've got our factors listed, but again, I can't include the number 1. If I can't include the number 1, it means I can't include this 12. So I can only work with these 2 sets of factors, and I can pick whichever one floats my boat. It'll work out the same in the end. So I can go the 2 times 6 or the 3 times 4. So, I don't know, let's go 3 times 4. So off my number at the top, I'm going to draw 2 little branches, and I write whatever the factors are. So I picked 3 times 4. So 3 times 4. Now, once I hit a prime number, I stop. Now 3 is prime, so I can't go any further, but 4 is not prime, so I'm going to keep going. So I've got down to 4, and I'm going to draw 2 branches coming off my 4. Now what numbers multiply together to give me 4? 2 and 2. So now 2's a prime, so I've actually hit the end of it. This is the end of my factor tree. So 12 can be split into 3 times 4, and the 4 itself can be split into 2 times 2. So what this means is that the number 12 is the same as 3 times 2 times 2. Awesome. Now if I wanted to write this in index form, which is what we're going to look at in a future video, I'm going to simplify this as 3 times 2 squared. There we go. We've got it in index form now. All right, let's create another factor tree, but let's pick a number that isn't one that we've already done. Okay, now let's do the number 24. Now 24 isn't down here, so we've got to try and come up with the factors ourselves. So what are some numbers that multiply together to give us 24? Well, we could go 3 times 8, or we could go, 3 times 8, 4 times 6, 2 times 12, or no, we can't put 1 times 24. So let's go 3 times 8. So we've got 3 times 8. So I had my big number up the top, I split it into 2 branches. Now 3 is prime, so I have to stop there, but 8 is not prime. 8 is composite, so I can keep going. So what numbers multiply together to give me 8? 4 times 2. So 2 is prime, so I have to stop there, but 4 is composite, so I can keep going. So 4 is made up of 2 times 2. There we go. Now I've hit all of the primes. I can't go any further with any of these numbers. You know what? I might actually circle my primes once I hit my primes so you can see. I'll do that on this one as well. All right, so the number 24 is made up of 3 times 2 times 2 times 2. Or if I wanted to write that in index form, that would be 3 times 2 to the power of 3. Awesome. And there we go. We have looked at prime numbers and how to create factor trees and then write it in index form. Thank you for watching.